Today's lesson is multiplying decimals by decimals. Okay, again, we hit this essential question. How can estimating be helpful? We've talked about it, we've seen it, we've done it in adding and subtracting decimals, and then we also did it somewhat in dealing with multiplying decimals by whole numbers, and it came out pretty good. And again, we're probably going to revisit estimating with multiplying decimals by decimals. And the less than essential question is, why is estimating not helpful when multiplying very small numbers such as 0.007 and 0.058. I'm sure we can even think about it because we were doing rounding and we've been doing rounding. If we rounded this to the nearest whole number, what do you think 0.007 would be and 0.053 would be? If we look at the very first number right to the right of the decimal, it's a 0. So we would round the whole number to 0. And then the other number, 0.053, we would also round to 0. And all we'd come up with is 0 every time, just about. So pretty much we can answer that question right now. Okay. When you multiply decimals, you do it just like we did yesterday. Okay? Except that instead of there being a whole number, there will be another decimal. Okay? When multiplying a decimal by decimal, multiply as with whole numbers. To place the decimal point, find the sum of the number of decimal places in each factor. The product has the same number of decimal places. Okay? We made a little formula or a logarithm in which we could do this. Okay? What we said was, we said this. Remember this in our notes? On multiplying decimals, we set up the problem. Okay? Just like over here, look. 3.6 times. Okay, we have find 3.6 times 0.05. We don't multiply like that, right? We like to multiply like this. 3.6 times 0.05, or, 0.05 times 3.6, okay? I know that most of us like to put the bigger number digit on top. I'm okay with that. It really doesn't matter because order does not matter when we multiply. Okay, which we will talk about later. Okay, 2, okay, we multiply as normal. Right? So we just do our regular multiplication. All right, we come up, see, I really don't know. See, yeah, right, here. See, there's only one number to multiply with. Using this one would cause a little bit of more work for us. So I will use this one right here, okay, just like they have done over here. And as the everything suggests, right, 15 is 18, right? So we multiply it as normal. Now we have to count let me see how we did it in our notes. We count the numbers to the right of the decimals. All right? Okay? Meaning this, all right? How many numbers are to the right of this decimal? There are 1. How many numbers are to the right of this decimal? There are 2. Okay? We add them together and we have 3. So that means we have to give this 3, which is now we've counted, right? And our fourth step is give that. Let me see, how did I word it again? We talked about, no, it's not give that. Give our answer, that many. And here's the word that I use. Remember, I'm hoping that it'll help you to remember to do this for multiplying. Give that many wubbas. I know, for you who are seeing this and have not taken my class, okay, it's a new word for you. It's no big deal. These are my wubbas. 1, 2, 3. Look, it makes it makes a W and a U. Whoa. All right. Okay, no big deal. All right. So we give them that many wubbas or that many decimal places. Okay. So we added up the decimal places right here. Right. 1 plus 2. We made it 3. And we gave our answer that many decimal places, or as I call it in my class, wubbas. All right. And then we're done. Look, we got the exact same answer. That's fantastic. Right? Okay, on to the next page. Okay, again, we could just fill this out. This is no big deal to fill out. They want us to estimate, which, you know, they were talking about these infinitely small numbers. This is going to be 0 times what? 7? And that's going to be 0. That's why it's really kind of useless to be estimating with such tiny numbers such as 0.112, because when we round to the nearest whole number, it's going to just turn into a 0. Okay, so they don't set up the problem. They set the problem up here. This is our step 1. I'm just going to write 1. Then in 2 here, what they did is sorry, that's not it. 2 here, which is going to be here, they're going to multiply as normal, so we'll just go to that. 2 times 2 is 4, 2 times 2, we got to annex a 0, right? It's 4, carry the 1, 7, 8, and then 7, and we do some adding. 4, 6, 0, 8. Did I do that wrong? I just look, okay, maybe not. Okay. All right. So then they say step 3 is they want to know how many decimal places, which I just put it over here. This is where I usually do my step 3. We have to count the number of, we have to count the numbers behind to the right of the decimal place. Here we have 3. Here we have 1, which I'll put those numbers here. 3, 1. Okay. Has 3 plus 1 is 4, which is, that's what I do here. Okay, that's why I do all this right here. Okay, right next to the number. I usually write, that's why when I set up my problems, I work on the left side of my page and I do all my labeling on the right side. Okay, so that means I have to give this 4. This is our step 4. I'll label it right here and point at it. 1, 2, 3, 4 wubbles. Right, that's our number 4 right there. Ta-da! And we got it, right? 0.80464, sorry. 8064. And when we check for reasonableness, you know, the sad thing is, whoop, I don't know what that's doing there. Go away. Boy, stop. Okay. Is check for reasonableness, right? They say that 0.8064 is kind of close to 0, I guess. It's such a small number. When you start rounding with these tiny numbers, you start coming up with 0. Really 0, I don't know. That's up to you. Okay. All right, we're going to do these problems. Okay. We're going to do them by steps, just how I normally do it. The first thing we do, step 1, is set up the problem. Times 2.8. Right? And then we multiply as normal. Step 2 is multiplying as normal. 8 times 7 is 56. Carry the 5. That's 5 times 8 is 40, plus 5 is 45. Right, annex is 0. 2 times 7 is 14. 4, carry the 1. 5 times 2 is 10, plus 1 is 11. That's 6, 9, 5, 1. Right, now we do that was step 2. Step 3, right? We count the numbers behind, to the right of each decimal. 1 plus 1 is 2. Okay, put my little addition sign. 2, and I give myself 2 wubbles, or 2 decimal places, okay, to keep things straight. I think I might be able to do this all right here without having to move around too much, so I'll go ahead and continue. Step 1 is set up the problem. 4.12 times 0.05. Excellent. And okay, now step 2 is multiply as normal. Okay, 5 times 2 is 10, 0 carry the 1, 5 times 1 is 5, plus 1 is 6, 5 times 4 is 20. Annex is 0. Oh, don't need to. We're done with that. All right. Then we got to count the number of count the numbers behind to the right. How many numbers there are to the right of each decimal? Right. There's 2 and 2. We add those together and we come up with 4. So we got to give ourselves 4 wubbles. Okay. And do we all recognize that 0.2060 is the same as? I'll just put. No, I'm not going to put equal. I'm going to put or. Or 0.0, of course I can't write it now, 0.206 is the same, right? You guys know that. Okay, you can drop that 0. All right, working on C. First thing I'm going to do is set up the problem. I'm going to put the bigger number on top, just the one with the most digits, like they come out wrong. All right, setting up the problem. My second step is going to multiply as normal. 7 times 4 is 28. 8 carry the 2. 7 times 1 is 7, plus 2 is 9. All right, and you got, I won't worry about the zeros. Okay, I got to annex the first 0 here. 3 times 4 is 12. 2 carry the 1. 3 times 1 is 3, plus 1 is 4. And again, I'm not going to worry about the rest of the zeros. Okay. Some of you might. I told you in class that I sometimes do. All right. Just this time I'm not going to. And see what happens. But it looks like I'm probably going to have to annex a 0. All right. 8 plus 0 is 8. 9 plus 2 is 11. Carry the 1. 4 plus 1 is 5. All right. We're done with step 2. Step 3 is we have to count the numbers. We have to find out how many numbers are to the right of the decimal places. Okay. 3 plus 1 is 4. Okay, and then we got to give that many wubbas. 1, 2, 3, 4. Now the reason why I did this on purpose was to remember, if you have an empty wubba, you have to annex a 0. Okay, just remember that. I'm sure we talked about it, but I don't know if I hit it hard enough in the last lesson. Which I think what I'm going to do is I'm going to go back and redo the last lesson. Okay, moving on. Again, we'll go ahead and read this first part, right? You know, find 1.4 times 0.67. They set the problem up, right? 1. They multiply as normal. 2. They count the numbers behind the decimal place. This is 3. And then the step 4 is, and they have to give it 4 decimal places. 1, 2, 3, 4. They really don't show you doing it. And here they had to annex a 0. They even talk about it. Annex a 0 to make 4 decimal places. Okay. In your math folder, if you wanted to fill this in, you can. Okay, I'll do it for you real quick. All right, the product will have blank decimal places, annex zeros. Okay, it's asking a question right off. That's okay, we can figure that out because all we do is figure out what the product will have. We just add up the decimal places here. This one has what? 2, and this one has 3, and so we'll have a total of 5 decimal places because 2 plus 3 is 5. Be sure we can answer questions out of turn. All right, they set up the problem. We'll go ahead and do our multiplication. 3 times 5 is 15. 5 carry the 1. 4 times 3 is 12, plus 1 is 13. Okay, and that becomes a 1. We annex a 0, which they do not do, which is kind of disturbing. 5 times 5 is 25. 5 carry the 2. 4 times 5 is 20. 0 plus 2 is 22. Carry the 2. And then 5 times 0 is 0 plus 2 is 2. Okay. 5 plus 0 is 5. 5 plus 3 is 8. 2 plus 1 is 3. 2 plus 0 is 2. We have to give it 5 wubbas. 1, 2, 3, 4, 5. So we have to annex. When there's an empty wubba, we have to annex. All right? And I guess we can check by multiplying. I'll just do it real quick. 12, 13, 5, carry the 2, 22, 5, 8, 3, 3. Sure, at least the multiplication came out right. Great, we're just checking multiplication with multiplication at this point in time. Okay, move the decimal place 5 places here. Sure, and that'll be 0, 2, 3, 8, 5. That means we did our multiplication right. Yes, this is the same. Okay, there's nothing wrong with working with it. Okay, next page. I'll go ahead and again, I'm just going to do it by formula. Excuse me, my formula that I use, right? I set up the problem. 0.32 times 0.04. If you want to, you feel more comfortable having that other 0 there, that's fine. Just remember to put your multiplication sign. And look, the decimals line up. That's why the decimals lined up, right? Okay, that does not make it, you still have to multiply as normal. Okay, 4 times 2 is 8. 3 times 4 is 12. Okay, now we start counting decimal places. This one has 2. This one has 2. It's 4. We got to give it 4 wubbas. 1, 2, 3, 4. We have to annex a 0. Okay? We now have to annex a 0. It's important that we talk about that. I'm glad that this is doing that. Okay? First thing over here, step 1 is set up the problem. 0.205 times 0.26. Okay? 5 times 6 is 30. 0 carry the 3. This is going to be 3. And then that's going to be 12. Annex is 0. 2 times 5 is 10. Carry the 1. This is going to be a 1. That's going to be a 4. Okay? So I need to count the numbers behind the decimal place. There are 3 here. There are 2 here. 2 plus 3 is 5. So we need to give our answer 5 Wubba's 1, 2, 3, 4, 5. Okay, we'll call it all sorts of things. Okay, but it's moving the decimal place, right? Wubbas are just moving the decimal place. Just trying to get you to remember to move the decimal place by saying wubbas. Okay, last one. Set up the problem. 1.33 times 0.06. That's step 1. Step 2 is multiply as normal. 18. That makes us 19, and that makes that a 7. And then we need to put our decimal points. 2, 2, gotta give it 4. 1, 2, 3, 4. Excellent. Okay, let's do our last problem. Okay, I'm gonna put, I gotta remember to put the shade up on these. A certain car can travel 28.45 miles with 1 gallon of gasoline. The gasoline tank can hold up to 11.5 gallons. How many miles can this car travel on a full tank of gas? Justify your answer. Okay, so we know how we will go ahead and do cubes. It will circle any key numbers. Okay. Okay, now there's another number here that we need to circle. 1 gallon. Okay, we should circle probably, instead of just the number, is probably the descriptor of what that number is. That is number, that's miles, and this is gallons. Okay, it says how many miles can this car travel on a full tank of gas? And if a gasoline tank can hold 11.5 gallons, and it can go 28.45 miles with 1 gallon of gasoline, all right? So our next step is to underline the question. Oh, that's not part of the question. And then we have to find a box any math action words. The math action words in this, how many miles? How many? Right? How many miles? Excellent. Now we have to evaluate. Well, we know we're going to have to use multiplication, right? We have to look at it, which is just another form of adding, right? It's just adding hyper addition. We need to add 28.45, 11.5 times is what we have to do. But we can't just do that. So we're instead of adding it that many times, we're going to use multiplication. So we need to set up the problem. 28.45, sorry, times 11.5. And we do the multiplication. And look, we did it. Okay? This one has 2 decimal places. This one has 1 decimal place. 2 plus 1 is 3. So they had to give their answer 3 decimal places or 3 wubbas. Let's see. There you go. Okay? Outstanding. Not that hard. We start the guided practice. Thank you.